Okay, so for the practical examples we are going to create, we are using Collabolab, which is a Python environment freely distributed by Google. But you can use any development environment you want, for example, PyCharm, which is free and is very often used by Python users all around the world. So first of all, we must import the matplotlib library in our environment. We are going to start by using matplotlib. So first thing is to import matplotlib.pyplot, which is a specific instrument as PLT. So with this command, we import this tool from the matplotlib library, and we nickname, let's say, we call it PLT. So to refer to this tool, we just have to write down PLT. Then we have to create a fictional data set. For example, here we have a data set on apples yield per hectare, for example. You can see this, this is a list in Python. You can recognize it because we have square brackets. And of course, to draw a chart, we need a y-axis and an x-axis. So the yield here will be our y-axis. And of course, we will have years as an x-axis. So now that we have data for both of our axes, we very simply call the plot command. So we invoke the library PLT. We have nicknamed our library PLT. We use the plot command and give this command some parameters, basically the two axes. So years will be our x-axis and yield apples will be our y-axis. And then we press run to run the code. And as you can see, here we are. We have a very simple line chart plotted automatically thanks to basically 4 lines of code. We can personalize the chart a bit. For example, we can put a label on the axis, for example. With the command x label, we are going to create a label for the x-axis, and it will be, of course, years. We can do the same for the y-axis, and we call it, I don't know, production per hectare. We run the code again, and as you can see here and here, now we have labels that clarify the meaning of the axis. We can also give a general title to the chart. We can use the command title, and this can be, for example, a production of apples per hectare in Italy, for example. And again, we can run the code and we can see that we have now a title. Okay, so move on to more specific commands. I would like to, for example, plot different data sets on the same chart. For example, we can have, I don't know, oranges yield here. And here we have strawberries, okay? Now, we can just add our new data here. By invoking the plot command again. And then run the code. And as you can see, Python automatically choose a color, a different color, so that we can very, very easily make some analysis of different data, of different products in this case. Now, let's say that we want to personalize this chart a bit. It's time to import also Seaborn. Seaborn will help us personalize this chart. We will import Seaborn, calling it SNS, so that it will be very useful to recall it. And for example, thanks to Seaborn, we can set a style for the chart. The command is set_style, and there are there is a list you can find in the documentation of Seaborn. There is a list of customizable background for our chart. For example, we can use dark grid and then run the code to have a gray grid that help us clarify the position of the data, for example. But we can also use basic internal command of matplotlib to further customize the data visualization. For example, we can use marker here in the plot command. We can specify a kind of marker as a parameter. For example, one of the accepted marker is a circle that we can indicate with a O. And another one is a triangle that we can indicate with a V here. And there is, for example, a cross that we can indicate with the X. And as you can see, by running the code, there is probably an error somewhere. Yeah, we missed the marker parameter here. Sorry. Now, you can see some markers have been put on the lines in the chart so that they are more distinguishable. We can also, by using always matplotlib, change the size, for example, of the chart by using the figure command. The figure command needs a fig size parameter that takes a tuple. A tuple is in Python is basically a couple of numbers. In this case, the dimension of heights and weight. So we can put, for example, 12 and 6 here. Running the code, we will see that sides here we missed. Sorry. Okay. We can see that the chart has changed dimensions here. So we put 12 for width and 6 for height. And here we are. And finally, we can add legend to this chart. The command is very intuitive, is plt.legend. And then we need a list of the names we want to appear in the legend. Keep in mind that the name should be in the same order that appears on the code when we plot the line. So as you can see, we are plotting here the apples first, then the oranges, then the strawberries. So to make the code understand what legend should refer to what data, we should follow the same order. So here we have apples, and then we have oranges. Again, this is a list of strings. As you can see, they are strings because they are inside quotes. And this is a list because the list of strings is inside square brackets. And last is strawberries. Yes. Then we run the code. And as you can see here, a legend has appeared. So now we can refer exactly each line, not only by the marker, not only by the color, but directly by reading on the legend.